I know calculus is often seen as one of the key markers for higher level mathematics. Concepts like differentiation and integration are at the heart of countless real-world applications. From engineering design in cars and buildings to the technology behind the phone or laptop that you are using to watch this video. But if you ever struggle with calculus, it might be because you haven't fully grasped one of its foundational concepts, limits. Well, that's what we are going to discuss in today's video, so you will have a clear understanding and be more familiar with limits, which will serve as a groundwork for mastering calculus. Let's start with the definition. As the name suggests, a limit describes the behavior of a function as the input approach a specific value. It tells us the value that a function approaches as we get closer and closer to a certain point. For example, let's consider the function f(x) equal 1 over x. We can observe that as x approach infinity. Mathematically, we use LIM as a notion for limit. We will get this. So, by dividing 1 by a really large number, we will get a smaller and smaller value approaching 0. So the value of f(x) will get closer and closer to 0. Let's look at another example. Consider function f(x) equal x squared minus 1 over x minus 1. This time, what will happen as x approach 1? If we simple substitute x for 1, we will get 0 divided by 0, which is undefined. However, using the concept of limits, we can analyze how the function behaves as x gets closer to 1 from both sides. To make it easier, let's simplify the function first. So from this, we know that x squared minus 1, we will get x minus 1 multiplied by x plus 1. From this, we will get x plus 1 when x is not equal to 1. Now, let's look at the limit. Limit x approach 1 from the left side of f of x will be equal to limit x approach 1 from the right side of f of x, which is limit x approach 1 of x plus 1. Substitute the value and we will get 2. Now let's look at the graph. As this is fx equal y and this is x. We will get something like this. As this is x equal 1 and y equal 2. Even though this function is undefined at x equal 1, which make it not continuous, we know that as x get closer to 1 from left and right side, fx approach the value of 2. Limit x approach 1 fx will be equal to 2. Now let's look at the example where the left hand limit and right hand limit are not the same. Consider the function fx equal x plus 1 over x. Now let's see what happens as x approach 0. If we try to substitute x equals 0 directly, we will get 1 over 0, which is undefined again. So let's take a look at limit. First, we can try to simplify the function to this. Now we can use limit. Also, for the property that we are using here, this is something that we call sum rule or sum property of limits. When we have limit of x approach c of f of x equal L, and if we have limit x approach c of g of x equal m, we will get that limit x approach c of f of x plus g of x will be equal to limit x approach c of f of x plus limit x approach c of g of x, which is L plus m. You can see it from here and here. For limit of constant, we will get the constant. So what we have to consider is this. For limit x approach 0 of 1 over x, we can see from two sides. For the left hand, we will get this. And for the right hand, we will get this. So for better understanding in terms of graph, as limit approach 0 from the left side, we will get minus. And for limit approaching 0 from the right hand side, we will get plus. So x approaching 0 from the left hand side, x will be very small minus number. So we will get minus infinity. And for the right hand side, x will be positive small number. So we will get infinity. Now we can see that since the left hand limit and right hand limit are not the same, and also because we cannot define infinity, we can say that limit x approach 0 f of x does not exist. Now to sum everything up, from the three examples, we've seen that even a function is undefined or discontinuous at a point, if the limit from the left side equal the limit from the right side, we can determine a clear limit value. I hope this video is helpful for your calculus journey. Thank you so much for watching. If there are other topics you'd like me to explain, let me know in the comments below. See you next time. Bye bye.